Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe the channel. Here is a problem. AD, BE, CF are the altitudes of triangle ABC. RQ is passing through D, and RQ is in parallel with EF. R is on AB, Q is on AC. So due to the drawing issue, at very first I just marked this point C here, but it looks like a little bit distraction, so I just remarked the C here. Okay, and EF meets CB extension on point P. Prove that the midpoint of BC, which is point M, is on the circumcircle of triangle PQR. So basically this problem is asking us to prove that PQMR is a cyclic quadrilateral, right? These 4 points are cyclic, so prove that PQMR are cyclic. So if we think about the ways that we can prove 4 points are cyclic, we have the way. By the way, in the Chinese version of this problem, I show the ways that how we can write it down in an exam, right? But in English version, I want to show the way that how I think of this problem, how I find the break point, and how to solve it in a reverse way, right? Okay. So we want to prove that PQMR are cyclic, right? The way that we can prove the 4 points are cyclic is to show that the seam chord, the angles reference to the seam chord are equal, right? That's the first way. And another way is to prove that the opposite angles, inner angles, the sum of the opposite inner angles is 180 degrees, right? That's the second way. And the third way is a Ptolemy theorem, right? And the fourth way is to use the power of a circle, right? So we find the two lines and they meet on a point. That means we can find the power of this point to a circle. And if they're equal, then these 4 points are on the circle, right? That's a fourth way. That's a very common methods we used in proving 4 points are cyclic, right? And for this problem particularly, can we use the first three ways, right? To prove the angle equal? That's kind of difficult, right? To prove the sum of the opposite inner angles to be 180 degrees, that's also kind of difficult. That's kind of similar to the first methods. And can we use the Ptolemy theorem? Obviously not, because we don't have any relation, segment relations like ratios or like in just as the parallel line cannot provide us enough relations, right? So the Ptolemy theorem is not suitable for this problem. And then the fourth problem is the power of a point. And if you look at this figure, we want to prove that P, Q, M are cyclic. And we know that MP and RQ meets on point D, right? Which means if we can prove RD times DQ equals to MD times DP. Or let me just rewrite this. DR times DQ equals to DM times DP. Right? If we can prove DR times DQ equals to DM times DP, that means we finish the proof of RMQP acyclic, right? So we want to prove this. And how can we prove this? DM, DP, DR, DQ. So we want to find the production of DR and DQ. And that means DR times DQ equals to something. And we want to prove DM times DP also equals to this one, right? Now let's just use what we have here, that FE is in parallel with RQ, right? That means angle AFE equals to angle ARQ, right? This one is in parallel, FE is in parallel with RQ, so angle AFE equals to angle ARQ, right? And let's connect FD and ED. So based on the properties of the Orthocenter, I'm not going to repeatedly prove things that I already teaching in previous video, right? Please reference to the properties of the Orthocenter video that we already proved that angle AFE equals to angle DFB, right? And we already know that angle ARQ equals to angle DFB, which means angle DFR equals to angle DRF, right? Because angle ARD, that's angle DRF, and angle DFB, that's angle DFR, right? So these two are equal. So 1 equals to this one, equals to this one, which means FD equals to, or DF equals to DR, right? DF equals to DR. Similarly, we have angle AEF equals to angle AQR, right? This angle equals to this angle. AEF equals to AQR because FE is in parallel with RQ. And we already know that angle AEF equals to angle DEC or DEQ. And angle AQR can be rewritten as angle EQD. So we know that angle DEQ equals to angle DQE, which means DE equals to DQ, right? So we just get DR equals to DF and DE equals to DQ. That means DR times DQ equals to DF times DE, right? Then the problem is that can we prove DF times DE equals to DM times DP? Can we prove this? We want to prove that DF times DE equals to DM times DP. And notice that angle, assume this is valid, right? Assume this is valid. And we notice that angle FDM equals to angle EDC or angle EDP, right? So if this is valid and this is true, that means the triangle FDM is similar to triangle DEP, which means we just need to find another way to prove that triangle FDM is similar to triangle FDM, right? So PDE, right? We just need to find another way to prove that. Let's just connect to FM. So to prove, we already have the ratio here. That means we want to get the conclusion from the similarity of the two triangles, right? We want to use this as a conclusion, which means to prove these two triangles to be similar, we need to use angles, right? And if you still remember the 9-point circle here, this would remind you, right? Every time you see the altitudes here and you see the midpoint just related to the 9-point circle, right? So I will briefly prove the 9-point circle again in this video, but please refer to the videos I talked about the 9-point circle before, right? I mean, repeatedly proving something is not very helpful. So, based on the 9-point circle, we know that FEDM are cyclic, right? So let me just retell the 9-point circle here. In a triangle ABC here, the DEF, which are the foot of the altitudes, and the midpoint of 3 edges, AB, BC, AC, and the midpoint of, so the orthocenter is H, right? The midpoint of AH, BH, CH. These 9-point circle are cyclic, right? Okay, let's just use this for now. We know that FEDM are cyclic, which means, so these are the target, right? We know that we know that FEDM are cyclic, which means angle DEP equals to angle FMD, right? Angle DEP, this one, equals to this one, FMD. And we already know that angle FDM equals to angle EDP, right? Based on these two, we can say that triangle PDE is similar to triangle PDE is similar to triangle FDM. So we have FD2MD equals to PD2DE, which means DF times DE equals to DP times DM. And we just proved that DF times DE equals to DQ times DR. So we know that DR times DQ equals to DP times DM, which means R, P, Q, M are cyclic. Right. Okay, so this problem, that's the way I think of this problem. The first thing is that how we want to prove that 4 points are cyclic, and which method we should choose in proving that 4 points are cyclic. And based on that thought, I choose this way, and then I try to find the relations and derive to here, right? That's a start point, and that's a break point. This is a very, very critical part. So for the audience that may not familiar with 9-point circle or already forget about the 9-point circle, I'll just briefly prove that again here. Please bear with me. Okay, we just want to prove because all these angles, all these proof can be rotated, changed to the midpoints on the AB or AC. So I just need to prove that on the BC, the midpoint on the BC is on the circumcircle of the triangle FDE. That's enough, right? So angle FDE equals to, we already know that angle FDB equals to angle EDC equals to angle BAC, right? Based on the property of the orthocenter. So angle FDE equals to 180 degree minus angle EDC minus angle FDB, which means 180 degree minus twice of angle BAC, right? That's the angle FDE. And what about angle FME? Because triangle BFC is a right triangle and triangle BEC is a right triangle, so we know that MB equals to MF equals to MC equals to ME, right? That means angle FME equals to 180 degree minus angle FMB minus angle EMC, right? So this is true, and it equals to 180 degree minus, what is angle FMB? FMB is 180 degree minus twice of angle ABC. And what is angle EMC? That is 180 degree minus twice of angle ACB, right? So it equals to twice of angle ABC plus twice of angle ACB minus 180 degree. So it can be rewritten as twice of angle ABC plus twice of angle ACB plus twice of angle BAC minus twice of angle BAC minus 180 degree, right? Plus 1 minus 1, these two cancel. So it equals to twice of 180 degree minus 2 angle BAC minus 180 degree. So it equals to 180 degree minus twice of angle BAC, right? So it equals to angle FDE, which means FMDE are cyclic. And for the midpoint of BH, right here, let's call it K. So the angle FKE, right? Angle FKE equals to angle BFK plus angle FBK, right? And because I write FKE, yeah, FKE is angle FKH, right? So because triangle BFH is a right triangle and K is a midpoint of BH, so we know that BK equals to KF, right? So the angle KBF equals to angle BFK, right? These two angles are equal, so it equals to twice of angle FBK. And angle FBK is angle ABE, right? Equals to twice of angle ABE. And angle ABE, because triangle ABE is a right triangle, so angle ABE equals to 90 degree minus angle BAE, which is BAC. So it equals to 180 degree minus twice of angle BAC, right? It equals to angle FDE, which means FKDE are cyclic. So the midpoint of ABAC BC and the midpoint of BHAH CH and the foot of the altitudes D, E, F. These 9 points are cyclic. Okay. For this problem, if you know the 9-point circle, it's not very difficult. So please just review the videos, revisit the videos that we discuss about the 9-point circle. All of these knowledge are correlated, right? Okay, I hope you like this problem and I hope you like this video. See you in next one. Thank you.